In this session, I am going to derive the expressions for change in entropy in terms of temperature, volume, and pressure. First of all, I want to derive the entropy, change in entropy for in terms of temperature and volume. As you know that, according to the first law, Q is equal to U plus W, that is, you can write this as dq is equal to du plus dw. Then dq is equal to, as the formula for internal and change in internal energy, mcv dt for the work done. This is p dv. For this, dividing both sides by t, that is dq by t is equal to mcv dt by t plus p by t dv. Here you can write this dq by t as ds and p by t as mr by t. It is from the gas equation, that is p by v, not t, sorry, that is p is equal to mrt. So from this, dq by t is equal to ds is equal to mcv dt by t plus mr by mr dv by v. From this, you can integrate 1 to 2, T1 to T2 from initial state to final state, that is V1 to V2, that is S2 minus S1 is equal to MCV. As you know, the integration of dt by t, dx by x is, that is log x, that is log T2 by T1 plus MR log V2 by V1. This is the general expression for change in entropy in terms of temperature and volume, that is mCv log T2 by T1 plus mR log V2 by V1. Now I am going to derive the entropy in terms of temperature and pressure. So as you know that P1 V1 by T1 is equal to P2 V2 by T2. From this you get that V2 by V1 is equal to P1 by P2 and T2 by T1. You can submit this equation into this V2 by V1, that is S2 minus S1 is equal to mCv log T2 by T1 plus mR log V2 by V1. Instead of V2 by V1, I post, that is P1 by P2 into T2 by T1. Here mCv log T2 by T1, using the log function, using log function, that is log AB, you can write this as mR log P1 by P2 plus mR log T2 by T1. You can here log T2 by T1 and log T2 by T1 m. So you can take this common as log T2 by T1, that is CV plus R plus mR log P1 by P2. you can take m as common, log Cv plus R log P1 by P2. This is Cv plus R. By using the relation Cp minus Cv is equal to R, that is R plus Cv is equal to Cp. It is log T2 by T1 into Cp plus R log P1 by P2. You can modify this equation as Cp log T2 by T1 plus, at the same time you can also modify the P1 by P2 and displacing, that is placing minus, you can change this as R log P2 by P1. This is the general expression for change in entropy in terms of temperatures and pressure. In this, we simply modifying the equation 1, that is in terms of temperatures and volume, by placing V2 by V1 instead of by placing this relation P1 by P2 and T2 by T1 in place of V2 by V1, you can get this simple. After that, now we are moving to the derivation for in terms of temperature and volume, temperature and pressure, and pressure and volume. You can write this equation, that is S2 minus S1. S2 minus S1 is equal to m Cv log T2 by T1 plus R log V2 by V1. You can change this T2 by T1 as T2 by T1 is equal to P2 by P1 into V2 by V1, like this. Here we modify this, that is P1 by V1 by T1 is equal to P2 by V2. With this you can also, from that you derive this equation. You can modify, that is mCv log, replacing the T2 by T1 as P2 by P1 V2 by V1 plus R log V2 by V1. Here, using the logarithmic function log AB, dividing this log P2 by P1 plus log Cv log V2 by V1 plus R log V2 by V1. Here you can look that, identify that these are the log V2 by V1, log V2 by V1. Cv log P2 by P1, make the common, that is log V2 by V1, that is Cv plus R. As the Cp minus Cv is equal to R, Cv plus, that is Cv plus R is equal to Cp. M Cv log P2 by P1 plus Cp log V2 by V1. This is the expression for change in entropy in terms of pressures and volume. You can identify that Cv for P2 by P1, Cp V2 by V1. Here also you can identify that that is the expression in terms of temperature and volume. Cv is placed for for in front of temperatures, and R in terms of volume. So now we can write the expression for all. S2 minus S1 is equal to M CV log T2 by T1 plus R log V2 by V1 in terms of temperatures and volume. M CV log T2 by T1 minus R log P2 by P1 in terms of temperature and pressures. That is CP log V2 by V1 plus R log CV log P2 by P1 in terms of P and V. These are the equations for change in entropy, and these are also called as a general expressions for change in entropy.